We are talking about slope today. We are going to find the slope of a line given 2 points on the line, given an equation, and interpreting slope-intercept form. Horizontal lines and vertical lines are special situations because the slope is basically two numbers or one, it's often a fraction, but it could just be one number that describes the steepness of a line. So is it okay? So we're also going to be comparing two slopes by the end. So parallel lines are like train tracks. It doesn't matter which way they're going, but they will never touch. I can't even draw them clearly. And then perpendicular lines are at 90-degree angles. I know it's a lot to like come into this class while it's recording. Try to mute your mic and everything. Perpendicular lines, sometimes you see that triangle, it just means they're at a 90-degree angle from each other. So perpendicular looks like this, parallel looks like this. And the way you find out is by comparing the slopes. And the slope is a number to describe the steepness of a line. How steep a line is would be the slope. I think in real life we use percents, right? If we're driving and you see a big hill, it'll sometimes, if it's like a dangerous hill, it'll tell you what percent grade it is. All right. So the slope of a line is from one point to another point on the line. Let's make it a negative slope. How many points, how many units up or down, and how many units right or left to get from this point to this point to stay on that line. All right. So in order to describe slope, I need two different points. We can call this point 1 and we can call this one point 2. Good. So if we're trying to find the slope of the line containing the points x1, y1 and x2, y2, those are subscripts. That just means we're talking about point number 1. Okay. These subscripts mean we're talking about the x value of number 2, the y value of point number 2. So that's just referring to point 2. That's why we would have a subscript 2 for those two letters. Good. So it's the notes are on Blackboard, yes. Where is it? I think as you go into start working and it outlines the units and when they're due, if you click on that unit, you'll see the notes. And then if you ever miss class and you don't want to wait for me to post the video because I'm taking too long, there's also a video under lecture videos at the bottom of all the notes. Someone asked, sorry. All right, so it's often a fraction, and what is going to be on the numerator of the fraction? Remember, this is numerator and denominator, not super important, but I say those words a lot, so that's what those mean. The numerator is always your up or down, so the change in y. The denominator is always the change in x, so left or right. Good. Y, right, is the axis going up or down. So our y value is always up or down. Our x value is always, left to right. Good. So when you have a slope and it comes as a fraction, oh, let's talk about this slope again. Okay. So if I was just to count up and down, how to get from this line to this line, I know I don't have units, but maybe this is just 1 unit down. Down means negative, right? So on my y value, I'm going, or on my y axis, I'm going down 1. Does that make sense? And then from that point, maybe I'm going 2 to the right, right? So down 1 to the right 2. My x is equal to 2 and my y is equal to -1. All right, so that's actually a slope of a -1/2. From this point, whatever this point was, I went down 1 and then I went so I went -1 on the y, +2 on the x, okay? Or, because it's a negative, you could also call it +1, -2 if we were going from this point to this point. It doesn't matter which point you start at, you should get the same slope because that is the same number as that is the same number as the negative out in front of that fraction, okay? Don't be intimidated by just the format of the fraction. Good? So from this point to this point, I went down 1 on y, right 2 on x, or from this point to this point, I went left 2 or -2 on x, +1 on y. All right. And we will keep talking about this, don't worry. So, nope, sorry, printed on both sides of the page. They are now asking you to find a slope of a line through 0, 3, and 2, 5. So this will be my point 1, my first point. So that means my x1 is equal to 0, my y1 is equal to 3. Excuse me. This will be point 2. So that means my x2 will be equal to 2, my y2 will be equal to 5, y sub 2. Good, I'll write this again too. Here's P1, so x1 equals 0, y1 equals 3. Any questions? All right, and then we're going to use what I didn't even talk about, but this the formula for finding the slope of a line. All right, so you're going to take your change in your two y values over your change in your two x values. So when we labeled it y2 and y1, we're going to take y2, subtract y1. Then for that bottom number for the denominator, we're going to take x2 and subtract x1. We're going to take that x2 and subtract x1. It doesn't matter which one you choose as P1 and P2, but you do need to be consistent, right? Don't accidentally flip these and go 5 minus 3 and then 0 minus 2. That would be wrong, but choosing which one is which, it does not matter. Okay, so I'll write our slope equation again right here. Our slope is rise over run, which is not technically part of it, but it's just good to know because I sometimes say it, right? Rise means up or down, run means left or right. So we're talking about the change in y for the top, y2 minus y1 over the run, x2 minus x1. Any questions so far? All right, so y2 minus y1 over x2 minus x1. Other questions? Feel free to interrupt, okay? So y2 is 5, y1 was 3. So that minus sign was a +5, -3, okay? Here, x2 is 2, x1 is 0. So our slope for whatever this line is, we don't know, is 5 minus 3 over 2 minus 0. 5 minus 3 is 2, right? And then 2 minus 0 is also 2. 2 divided by 2, if you put that into your calculator, any number divided by itself is just the number 1, okay? So what that means is, here's our P1, right? 0, 3. Here's our P2, 2, 5. That means to get from P1 to P2, I went up 2 and then to the right 2. It's also the number 1, so you can just go up 1 over 1 and do that twice. It doesn't matter how many times you do it, actually, because that graphing those 2 points will give you the exact same line as graphing starting here and ending here, right? It doesn't matter how many times you do up 1 over 1, up 1 over 1, up 1 over 1. It'll all always be on the same line. You can call it up 2 over 2. You can call it up 3 over 3. Good. So the slope of this line is equal to 1. We don't need to graph the line because it came graphed. Already right there. So example 2 says find the slope of the line containing the points 4, -3, and 2, 2. Graph the line. Also, this is a +1. So, sorry, I always imagine like somebody walking. You don't need that beginning of your line. Ignore that. But I imagine somebody walking, and if you are walking on your line and you go uphill, that's a positive slope. Okay. We're just talking about this part. This is a positive slope. If that's a number 1, then your line should be going in this direction. I'm going to show you this. On the other hand, if you are walking and you start going downhill, that is a negative slope. So if you see this line, your answer should have a negative in front of it. Okay, that's definitely going to be a negative fraction or a negative whole number. This, because it's going up, is definitely going to be a positive number. Good, but we're doing the exact same thing. So we're just saying m equals y1, y2 minus y1 over x2 minus x1. M is y2 minus y1 over x2 minus x1. Good. All right. Does not matter. I'll say x1 is 4, y1 is -3, x2 is 2, and y2 is 2. It does not matter which one is which one you make your first point and which one you make your second point, as long as they're together, okay? Those two have to stay together. These two have to stay together in the correct order. So now I'll rewrite it. That becomes 2 minus -3. There's always that minus, and if that number happens to be negative, we're going to do a minus a negative. x2 was 2 minus y1 is a positive 4. So we had one negative number. So that's going to end up as addition, right? 2 minus a -3 is the same as 2 plus 3. 2 minus 4 is equal to -2, or is the same as -2. So that would be 5 over -2, right? Which is the same as -5/2. So here, just like on that first page, -1 over +2 is the same as 1 over -2 is the same as -1/2. So it doesn't matter if you're trying to get from here to here. If you start at this point, you're going to go +1 on your y, -2 on your x, right? That's still -1/2. Or you can go -2 on your x, very afraid of saying the wrong word, +1 on your y. Okay, it doesn't matter which order, you'll still get a +1, a -2. And then same 2 points. If you start from the left side, now we're getting -1, -1, +2, or +2, -1. Okay, it's still -1/2. It just so happens that here the 1 is positive, the 2 is negative. Going this direction, the 2 is positive, the 1 is negative. So don't feel like you have to know which point to start at, or you have to know whether to use x or y first. Okay, it doesn't matter how you count for negatives. It will still end up negative no matter how you start. Positive will still end up positive. You can go, right? You can go from here to this point. So if I had to go all the way from here down there, I'm going to have to go down 1, 2, 3, 4, 5, 6, and then I'm going to have to go. So that's -6 on the y, and then that's going to be 1, 2, 3, 4, 5, 6, -6 on the x. So -6 over -6 is still 6 divided by 6 is 1. Negative divided by negative is a +1. So don't worry about where you start and where you finish, okay? So here we have -5/2. Let's see if on the graph that looks to be true. So if I start here and I go down 1, 2, 3, 4, 5, and then I go +2 on the x, I end up at that point. I went down 5, and then I went to the right 2. Any questions? So the slope is -5 halves. If I chose another point, it would be -10 fourths, right? -15/6. It's usually, the fraction is usually just in its lowest terms. All right, slope-intercept form of a line. When a linear equation in two variables is written in slope-intercept form, this is the most common form. This is the easiest form. This is like the one you remember. Y equals mx plus b, where m is the slope. So this number is always your slope when you have it set equal to y and in its simplest form. The number next to the x, or the number that x is being multiplied by, is your slope. And then your y-intercept is b. So your m is your slope, and b is your y-intercept. And so it's always written as a point, right? Your y-intercept is going to be 0 on the x, because you did not move off the y-intercept. And then it's going to be whatever that number is as the y value. For y equals 3x minus 4, the slope is 3, the y-intercept is -4. That means, so y-intercept is where you start. I start at -4. Here's my first point, because that is the point 0, -4, right? 0, -4 turns into a -4 in the y equals mx plus b equation. And then a slope of 3, you can always change a whole number to a fraction by putting it over 1. So remember, 3 is your y, +1 is your x. So I'm going to go up because it's a +3, up 3. It's also a positive x. Positive x is in this direction. So I'm going to go up 3 over 1 from that point or any other point I know on the graph, but that's the only point I know. Okay. So when you see this equation, it's actually enough for you to graph it. That's enough information. I need to go up 3 and then to the right 1. So from 0, -4, 1, 2, 3, I'm at -1 now on my y. And then I need to go to the right 1. So this will be the point 1, -1. If you put it into a graphing any sort of graphing application, you will get that graph out of it. Good. All right. Now example 3 wants us to find the slope of the line -3x plus 2y equals 11. We don't have points. Now we just have one equation, a linear equation in two variables. Linear just means it's a line. Two variables means the variable y and the variable x. So here's my x, here's my y. If I have all of that information, I want to put it into this form, y equals mx plus b. And then my slope is whatever x is being multiplied by. Okay. So we're going to solve this equation for y. It was -3x plus 2y equals 11. Good. Let's solve it for y just like we would solve anything else for y. So I'll just move the 3x over by adding 3x. Don't put it under the 11 because those are not actually like terms. 11 and 3x are separate, so they'll just have their own separate categories. Areas of the equation. So now I just have a positive 2y. I have that 11 and I have that 3x, but I like it in this format, so I'm going to put the 3x in front of the 11. It's a positive 3x, or it's plus 3x, so I'm going to put a positive 3x. It's a positive 11, so I'm going to add 11 behind it. Any questions? I just like it in mx plus b, so I move the 3 over here, the 11 over here. The 11 and the 3 are not like terms, so they have to be kept separate. That cancels that, and now I just have 2y. One more step is divide everything. If I want y alone, what should I divide everything by? Yes, that's what you were thinking, right? Okay, so now you have y is alone. 3x divided by 2 is the same. In this case, it's easiest to write it like this, right? Because that's the easiest way to see the fraction. Put the x out to the right. Because 3x over 2 is the same as 3 over 2x, because x is being multiplied by 3 divided by 2. X is being multiplied by 3 divided by 2. Everybody okay with that? Except that it's out of focus, constantly out of focus. All right. And then plus 11 over 2. We're just finding the slope, so I mean, even if we weren't finding the slope, there's no easier way to write 11 over 2. You can turn it to a decimal, but that's a fine way to leave it. You can't simplify it. They're only asking for your slope. Sorry. Your slope is the number that you're multiplying x by, so that's 3 over 2. That means you're going to go up 3 and to the right 2, or you would get the same line if you went down 3 to the left 2. Every time I say left or right, I have to be making that L with one of my hands. I'm very bad at left and right. So I hope I am not confusing you. Any questions?
What do we do with 11 over 2?
Good question. So that is just your B. So if they asked you to graph it, which they don't, here we said our B was -4, right? So you turn that -4 into 0, -4, because your y-intercept is going to be 0, B. B is your constant. So you know it's B because there's no letters, no variables. It's just a single number. Constant means you can't change it, or there's no variables next to it is the simplest way to say it. So you take that number and you turn it into 0, comma, whatever that number is. And then that's where you start your graph, because it's really your only point. The only point we know is that we can go to -4 on the y-axis and start, and then use our slope to go up, or honestly, to go down, right? So here, 11 over 2, it's kind of, it's just like not fun that it's a fraction, but if you think about, you're dividing 11 by 2, right? If it was 10 divided by 2, it would just be 5. And I'm going on my negative. So 10 over 2, and you're welcome to put it into a calculator. 10 over 2 is 5. 12 over 2 is 6, right? So 11 over 2 is actually just 5.5. It's right in between +5 and +6. So what you do is start your graph there. So start your graph at 11 halves. And then because you're so high, I would go -3, -2. So I would go down 3 to the left 2. Good. And then do it again. 1, 2, down 3 to the left 2. So this is your slope. So that's where to go once you have a point. And then this is always your point. So that always becomes 0 on X, B for your Y value. Because this is X, Y. So X is always going to be 0 because it's my Y-intercept where it crosses Y. So 0, B for that equation. Does that answer your question?
Yes, ma'am. Thank you.
Oh, thanks for asking. It's so exciting. All right, another one. Find the slope of the line -y equals 6x minus 7. All you need to do is set it to y equals mx plus b, and it looks like it's in y equals mx plus b form, but it isn't, okay? It isn't because of this negative. This is very important all through this entire course, and if you're going on to college algebra. This is not the same as this, okay? To get rid of that, you need to, if it was -5, right? if I wanted to make -5 into a +5, I divide it by -1, or honestly, you can also multiply it by -1. It changes the sign and nothing else. So if I want this -y to become a positive, I have to divide it by -1. Anything I do to this side, I have to do, sorry, that's not, that was my example question. I'm gonna write it again. -y equals 6x minus 7. It's not going to do anything to change the signs of those. All right. So if I want this to be a positive y, I'm going to divide by -1. Anything I do over here, I also need to do over here. So I can divide it by -1. That is also the same as 6x minus 7 over 1 is the same as 6x minus 7 multiplied by 1 over -1. Not to confuse you, but okay. So I'm changing and I need to distribute that to the 6x and the -7. So I'm changing this sign, and by doing so, I'm changing the sign of everything on the other side. Good. If you don't like division, you hate fractions, it's exactly the same as multiplying by -1. So I can take all of this and just say times -1 times -1. Just don't forget to distribute it. And you're just changing the sign, right? -1 times a -y becomes a positive y. 6x times a -1 is a -6x now. 6x times a, sorry, -7 times a -1 is a +7. So -y equals 6x minus 7 becomes y equals -6x plus 7. It's easier to say divide by -1, but it's probably easier to do multiply by -1. So this slope is not 6. I had to change all the signs. So my slope, which we always call m, is -6. My y-intercept, which they're not asking for, but it's good to be able to identify, is 7. If I were to graph it, I would start at, I always think it's a negative number, it never is. I would start at 0, 7. -6 means I go down 6. So I'm at +1, and then I'm going to go to the right 1. So there's my graph. Or I can go +6 on the y, -1 on the x. -6 on the y, +1 on the x, +6 on the y, -1 on the x. Either way, if they were asking you to graph it. So again, when they ask you to graph it, you start at the point 0b, and then you move m, move the slope. This is a negative slope, because if I'm reading it like I'm reading a sentence and I encounter it and I go down, that's a negative. Negative slope. All right, here's a real world example. The adult one-day pass price Y for Disney World is given by Y equals 3.53x plus 67.39, where x is the number of years since 2006. Use the equation to predict the ticket prices for 2026. So, this is a way to predict future events. You find an equation that describes the situation. You put your variables for the situation you want to plan for, and you get an answer. Okay. If the 3 is positive, if this 3 is positive, okay. Good question. So if this 3 is positive, why am I going down and to the left? I like the middle of the graph. So 3, 2, you're welcome to go up 3, because that's positive. Well, okay, first of all, let's start with on the y-axis. This is positive y, right? And this is negative y. On the x-axis, they should really make those letters further apart. This is positive, and this is negative, right? So for 3, 2, which happens to be way up here, it's a +3, +2, right? If I take +3 and divide it by +2, I get 1.5. However, 2 negatives being divided also gives me a positive number. So from 6.5, right? 5.5, from 5.5, from this point, 5.5, I can go up 3, and then in the right, in the positive x direction, and get this point. So that would be so that was 11. So that was 5.5. Now it's 6.5, 7.5, 8.5. So that's now 8.5. And then my x value is just 2, right? So I could get to that number on my graph. Or I could say +3, +2 is the same as -3, -2. So as long as I go in the negative direction on y and the negative direction on x, I will stay on that line because it doesn't really matter what points you choose. So that was 5.5, 4.5, 3.5, 2.5, -2. Good. Those are all the same points on the same line. So they don't really care whether you go in that direction or in that direction. And notice that even though I did double negative, it's not like I turned the line into a negative slope, right? It's still, when I encounter it, I go up. I naturally go up when I encounter it. If it was a negative line, I would naturally go down as I encounter it. So it's still a positive line. So what you want to check for when you're finding your slope and you're looking at your graph, besides just putting it straight into Desmos, which is a good idea, don't shy away from that. If it's a 3, 2, that means my line should look like this. I even like put a little note next to each when I find the slope. This is a positive slope. My graph should look like this. This is now a negative slope. I don't know how steep it is, but I know it needs to be going that way. Good. Good question. All right, so here, back to here, we know that y is our price and x is years, but not just years from the year 0. It's years minus the number 2006, right? Because right now we're at 2022, so that would be 22 minus 6, which would be 16 years, right? All right, use the equation y equals 3.53x plus 67.39 to predict the ticket prices for 2026. Y is our price, x is the years, but take away 2006 of the years. So 2026 minus 2006 gives us 20. So our x is not 2026, our x is actually 20, and y is what we don't know. So y is what we are solving for. Good. Now we just put those into our equation. Y equals 3.53, not x. I know that x is 20 plus 67.39. Good. 3.53 times 20 is 70.6. And then we just add it to that constant. Those two numbers added together is 137.99. I'm sure that's not true. I don't know. Who's been to Disneyland lately? How much does it cost? I bet it costs so much. So that's how you would solve it. That's just a good practice for solving, for knowing how to replace a variable with data to find information. Okay, vertical lines and horizontal lines. Sorry, 1 second. All right, vertical. It means up and down. Then we're going to talk about horizontal. That means, like, I think of the horizon. I guess you could call it left to right. Left and right. What do they call it? Rise. And then this is run. I don't know. I just think of a horizon, right? The sun rises over the horizon, the sun sets. Across below the horizon. There's the word. All right. So this is confusing because it's not in color, but we're talking about vertical. Looks like that. Horizontal looks like that, and what those slopes are. Okay. So remember that our slope, the equation of our slope, remember only write down what you need. I know I write down a lot. Our slope is y2 minus y1 over x2 minus x1. Y is always up and down, so we call that rise. X is side to side, so we call that run, okay? If you have a straight up and down line, it's all rise and no run, right? If I had to pick, and you are always welcome to just choose 2 random points on your line. So we will pretend like this is -1, 3, right? -1 on X, 3 on Y, -1 on X, -1 on Y. Good. And I could have chosen any points, but notice that my X, no matter what, is equal to -1. I made that up, but it's never going to change. I made up the spacing, right? I decided that that was 1 unit, but it's not moving off of that line, the -1 line. So my 0.1 could be -1, 3. My 0.2 could be -1, -1. That means my x1 is equal to -1. My y1 is equal to 3. My x2 is equal to -1. My y2 is equal to -1. If I put those into the equation, m equals -1 minus 3, and then over -1 minus -1. Good. All right, -1 minus 3 is -4. -1 plus a -1 is just -1 plus 1, so that's 0. So my slope is -4 divided by 0. What happens when we divide by 0? It's undefined. So anytime you have a vertical line, the slope is undefined because the bottom, whatever your y is, your y will be some amount, but your x is always equal to 0. The change in x, sorry. Here x is equal to -1 because it's on -1, but it doesn't change, right? Because slope is how much it changes. How much does it change in y? Doesn't matter, you can pick any point, right? It goes on forever. But between those 2 points, there's never going to be any change in x, and that is undefined because you can't divide a number by 0. Good. Remember that a vertical line is x equals, okay? If I made another vertical line here, that might be x equals a +4, right? There's not going to ever be a y equals that's vertical. If your equation has an x in it, it passes through the x-axis. If it only has a y in it, like this is y is 1, right? Then it's only going to pass through the y. And if it has both, like y equals mx or mx plus b, that's going to be that's going to pass through, for sure, it's going to pass through x and y axes. Okay. But if you just have y equals a number, we just say constant, right? Or y equal, you can even make it a number. Y equals a number. It will only pass through y-axis. It will never pass through the x-axis. All right. And then if you have x equals a constant number, it will only pass through the y-axis. Sorry, pass through the x-axis. I knew I'd get them confused. Does that make sense? So you crossed x. Up here, you crossed x, so it's x equals. Wherever you crossed x. Down here, this line is just y equals. Ooh, I said it's 1 and they say it's 3, sorry. This is just y equals, and it will only ever pass through the y axis. It will never cross the x-axis if it doesn't have an x in it. It will never cross the y-axis if it doesn't have a y in it. It just has x equals a number. Y equals a number, it'll look like this. If it's a diagonal, y equals x even, that will cross through both of them. Probably at the origin. That's a terrible drawing. All right. Y equals 2x plus 1. Good. Because I have the y and the x, it's going to cross the x and cross the y. If it only has y, it's only going to cross the y. If it only has x, it's only going to cross the x. This is always undefined because there's no movement on the run. The x's will always be 0, and the bottom of a fraction having a 0 is undefined. Now the slope of the line y equals 3. Again, we can just invent some points. So here is x is 0, y is 3. Here is x is -5, y is still 3. Good. So if P1 is -5, 3, you don't have to do this. You can just believe me. P2 is 0, 3. That means x1 is -5. Y1 is 3, x2 is 0, y2 is also 3. So there's your clue. Both of the y's are 3. So we start with m is y2 minus y1 over x2 minus x1. That's going to be 3 minus 3 over, what was x2? 0 minus -5. Ran out of space. Basically, it's 0 over 5. That is not undefined. If 0 is on the top, that's okay. Anything, take 0 divided by anything, you're going to get 0. So the slope of a horizontal line is always 0. So here the slope is 0. Here the slope is undefined. Because it is 0 over whatever your x is. Mr. Slope Guy, a face if you would like. Good. All right. I like to think of it as like I'm walking on the graph, but you can also make this face. So that is a positive slope. If I encounter it and I start walking downhill, that's a negative slope. Good. If I fall off a cliff, did you guys ever have to, did your other math teachers ever make you watch Slope Dude, the YouTube video? He's skiing and he goes, puff, puff, positive. No, no, negative. And then if he falls off the cliff, he screams, undefined. So you can Google that if you want. And then when he is on the flats and he has to just like crawl along on his skis very slowly, he says, this is 0 fun. This is 0 fun. So the flat slope is 0. The straight up and down slope is a screaming undefined. If I'm going uphill, it's a positive slope. If I'm walking and I'm going downhill, that's a negative slope. How much time do we have? Oh, class is over. All right, we're not going to talk about, that's a lot to talk about, parallel lines and perpendicular lines. I would not worry about it. I'm going to stop the recording. All right, these are all perpendicular examples. Parallel, easy. It's going to be the same number, right? The slope of line 1 is 5. The slope of line 2 is 5, not -5. Those are parallel. Perpendicular, if line 1 is -3/5, that means to make a perpendicular line, we need to flip the 5 and the 3. So now it's instead of 3/5, it's 5/3. And then we need to change the sign. Instead of negative, it's positive. Does that feel okay? Do another one. Line 1 is 10. Line 2 is -1/10, because 10 is the same as 10/1, right? Change the sign, flip the fraction, including making it a fraction. If L1 is 1/6, L2 will be -6. So on the exam, you'll have one question that asks you to determine whether the lines are parallel to each other. Your choices will be either they are parallel, they are perpendicular, or they are neither parallel or perpendicular. So make sure you can tell what parallel slopes look like and what perpendicular slopes look like and what they don't look like, what looks like close to that, but it's really a trick question. Okay. So what you want to do is find the slope. Remember, y equals mx plus b when m is the slope. These are not in slope-intercept form, so we're going to change them, right? -6x, -6x. So now we have 2y equals -6x plus 9. Divide by 2. It's just going to go on like that was over. Now we have y equals -3x plus, you can just leave that as 9/2. We're just looking for the slope here. So this slope would be -3. It's not 6. You have to put it into y equals and make sure y is alone. So this slope is -3. If this slope is also -3, they are parallel. If it's +1/3, they're perpendicular. If it's any other number, they are not parallel nor perpendicular. So same thing here. We're going to add 3x, -y equals 3x plus 3. Divide by -1, remember, or multiply by -1 if that's easier. -y divided by -1 is a positive y. 3x divided by -1 is -3x. +3 divided by -1 is a -3. So that is done. That slope is also -3. So these are parallel. The slopes are the same, so they're parallel lines. Parallel because this slope matches this slope. Perpendicular, remember, we're going to change the sign of the slope, and we're going to flip the fraction of the slope. Flip the fraction. Good. So x plus 3y equals -15 is our first one. We're going to subtract x from both sides. Now you have 3y equals -x minus 15. Divide by 3 to get y alone. So now I have y equals -x/3. Remember, there's an easier way. 15 divided by 3 is 5. There's an easier way to write this if you're trying to see a number in front of x. If this x is on the top of your fraction, you can also move it behind the fraction. Okay, so now we have y equals -3x minus 5. The x moved over to the side. Now there's nothing up here, but there was an x. So we're going to put a 1 in its place. And -x/3 is the same as -1/3 times x. Because in both occasions, you're taking x, you're dividing it by 3. Here we're taking x, we're multiplying it by 1, dividing it by 3. Okay. So here our slope is, and it was a negative, so I guess I should have been saying -3. Here our slope is -1/3 for the first one. And then we can look at the second one, which is -3x plus y equals -1. Add 3x to both sides. y equals 3x minus 1. Done. Y is alone. You're done. Now my slope is positive 3 for this line. Is negative 1/3 the opposite reciprocal of a positive 3? I have opposite signs, and if I was to flip this fraction, I would have 3/1. 3/1 is 3 because 3 divided by 1 is 3. So these are opposite reciprocals. So these are perpendicular. We also have a photo of what it looks like when they are parallel and what it looks like when they're perpendicular. Hopefully you have practiced putting things like this into Desmos, and then you can put it into Desmos. You'll be able to see if there's a 90-degree angle, or you'll be able to see if they go on and on forever in the same direction without touching. This is the end. Good question. This is still the end of 3.4. I have not started 3.5 yet. Last example. So this is what the exam question is going to be, okay? Not these numbers, but are the lines parallel, perpendicular, or neither? Good. You're just going to take this and you're going to solve it for y. So negative 5x plus y equals negative 6. Add 5x to both sides. It becomes y equals 5x minus 6. Good. This guy set it equal to y by saying x plus 5y equals 5. Good. Subtract x, 5y equals negative x plus 5. Divide everything by 5. Y equals negative x over 5, which is the same as negative 1/5 x plus 1. Good. All right, so we're only looking at our slopes. This one's a negative 1/5, and this one's a positive 5. Are those the same? No, so they are not parallel. Are they opposite reciprocals? What is the opposite reciprocal of negative 1/5? I would flip those, so it would be 5/1, and instead of a negative, it would be a positive. Positive 5/1 is the same as 5, so these are perpendicular.